technology and the DNA fingerprinting of earthworms using RAPD PCR was the research areas of a doctoral degree dissertation. Specialization includes storage entomology, safe storage guidelines, hermetic storage, alternate protein from insects, and waste management. It's a very interesting topic to learn about alternate proteins from insects. She has published more than 40 research papers, 20 book chapters, and 30 popular articles in national and international peer-reviewed journals. She has completed a government-funded research project from DST, DSIR, and CWC on phosphine and carbon dioxide combinations as an alternative to stored pest, effective pulse storage for better livelihoods of Indian farmers for the food and nutrition security in the new millennium, and the evaluation of multi-layered bag for its fumigation efficiency. She is also a recipient of MS Money Best Researcher Award 2022 for Storage Entomology Research and Kalam Research Award 22 for her outstanding contribution in entomological research and entomophagy. This entomophagy is also a very upcoming area, and she is also expert in this particular topic. And with this introduction, I invite Dr. R. Meenatchhi to present a topic on recent trends to reduce the post-harvest storage losses of food grains. Dr. Meenatchhi, over to you.
Thank you so much, sir. Thank you for the introduction. And on behalf of Niftam Tanjavur family, I welcome all those who have organized on behalf of Institution of Engineers India, Tamil Nadu Center, especially this 100 hours course on sustainable development of the nation. The role of engineers, we play a very major role, especially in this food processing sector is considered as one of the sunrise sector globally, especially in India. We are growing and now a lot of importance is being given. So now actually this first day is being given with the topic of food processing technologies for the sustainable development. Morning we had discussion presentation by Dr. V.S. Sinija as well as Dr. Anand Kumar. In continuation of that, especially in food processing sector, what is more important to achieve the security, food and nutritional security is we need to have a grain which is stored, right? The food has to be stored and we need to have adequate food for everyone. So that is what the millennium goals of FAO as well as WHO. So with that goal, today I'll be giving limelight on the recent trends, what are the technologies which are being adopted in order to reduce the post-harvest storage losses in food grains. So it is very important topic, and I thank for the organizers for giving this opportunity. Just to introduce the topic as well as the importance of food grain storage, we can see globally, if you take around 2 million food grains are produced globally every year, especially for the human consumption purpose or domestication purpose for animals, feed and everything. And if you see the current status of the food grain production, 314.51 million tons of food grain are being produced. We are self-sufficient, so we all are so proud to have ample stock of food grains. But at the same time, we have to think and we have to be ashamed that so much of food grains, not a small quantity, a very huge quantity of food grains are being lost every year. Now, if you see the current status, 13 to 18 million tons of food grains are being wasted. If you take the statistical data that shows around 1,350 crores worth of food grains are being lost. Okay, maybe these losses may be in different stages, and among them the storage is considered as one of the most important part where being lot of losses are occurring. So we need to give a lot of importance to reduce the storage losses. If you see this 13 to 18 million tons that are being completely produced by a particular country to manage the entire people food requirement. So we need to see what are the reasons which are there for majorly causing to this food grain losses. If you see the surplus stock exceeds the storage capacity. This is a major reason. Apart from our the existing storage capacity, we need to maintain a lot of bulk surplus of food grain. We knew, like, in order to face the calamities, as well as we need to maintain the PDS in order to provide record status, right? And also use of improper storage methods, that is a major loss which is caused especially during scientific storage of food grains, which is not existing, because if you see, around 60% of the storage that occurs at primitive level, remaining 40% only we are going, especially if you consider for the bulk grain storage, like CWC, FCI and other places. So huge quantity is being stored at farm level, and also constraints in liquidation of excess stock, as well as lack of interest in some places where there is no proper scientific storage that occurs. And if you see the farm level storage or the major practice of storage that occurs in India, that is the first picture that shows, we all knew, like, that is a cover and plinth storage. So we store it, maybe it may occur in the open warehouses also, or maybe in the stored godowns, right? In both the places, this cover and plinth storage is a major storage that occurs, especially with using the gunny bags. At the bottom, we put the wooden plank in the cement plywood platform. Then we will be storing our food grain, and we used to cover it with polythene sheet, multi-layered sheets. Then we go for fumigation to prevent the insect pest. So this is the common method of storage which we do it in India, especially in all the centers where we majorly go for storage. And what about the status in most of the developed countries? They all have shifted from bag storage to bulk storage. Now we are in the primitive stage, and we are also in the stage of transformation that we have to accept, and we have to proceed to go for the bulk storage in order to avoid the storage losses. It is a truth. And what we experienced from the developed countries, they all now, they have shifted from bag to bulk, especially in silo, as well as silo bags, bunker storage. There are different sort of storage structures are being used in order to store the food grains, and they experience a very less loss, as well as protection from stored pests too. So if you see the post-harvest losses, what we are talking based on our committee report, if you see the major loss, if you see from insects as well as rodents, they are the major contributor of storage losses. If you see 2.55%, insects, they are contributing. Similarly, rodents also, they contribute a major loss. Similarly, during transport as well as processing, then microbes, birds, moisture and threshing losses are very less when compared to the huge loss which experienced due to insects. So if you see what are the major factors which are affecting the grain storage, just we cannot think grain storage is a simple practice. Just simply we are putting the grains in bag and we are keeping. Whenever pests are coming, just we are putting some fumigant or chemical to control. This is not the truth. Actually, it has to be considered as the storage environment where the insects are living, our grains are respiring. So there are a lot of biotic as well as abiotic factors which play a major role. So if you consider the major abiotic factors, temperature, grain temperature is a very important factor to be considered. Then the grain moisture content, we need to dry to the safe moisture level, then we need to go for storage. As well as what about the intergranular gas composition? We knew in the normal atmosphere, we have oxygen, carbon dioxide and all the gases in particular composition. So whenever this variation in the intergranular space is there, that is very important. Whenever the oxygen in the granular spaces is more, the insects are more convenient, as well as whenever the grain moisture content is more, as well as grain temperature is high, we experience lot of insect damage. We can see when we compare to the tropical as well as temperate countries. Tropical countries like India, we experience lot of grain damage, especially where more of the temperature as well as moisture content increase is there. And if you see the countries where low temperature they are experiencing, they always the multiplication of the insects are very less, so that they could able to control in a better way also. So there is now a lot of concepts are being talked based on the intergranular space composition. Now we are thinking upon the controlled atmosphere as well as modified atmosphere storage, not only in packaging, even in grain storage also now this plays a major role based on the intergranular gas composition. And not only this is just dried grain, we keep it, which doesn't have life, we think, or that is a respiring organism, which really we keep it. Along with that, the insects are also growing. Also, the other organisms like mites, which we cannot see like insects, they also contribute a lot of losses, as well as fungus, along with the high moisture content, along with the insect infestation, which may cause a lot of toxins too. So these all the things needs to be managed if we wanted to go for the safe storage of the food grains. And if you see the different types of storage structures, what we use, starting from traditional to improved storage structures, now we are with, also now we are shifting to the modern grain storage structures. Till we are also using the traditional storage structure using gunny bag. And the storage facility, what we expect, must satisfy these following aspects, which should give a complete protection, not only from the insects, not only from the biotic factors, also from the environmental abiotic factors. Also, it has to be very easy to handle. It is what very, very important we need to see based on the manpower requirement, loading, unloading, cleaning, as well as inspection. We always involve a lot of manpower, and we always require continuously this manpower support. So any facility, if you want to modernize, the method which we develop should be easy for handling inspection, loading, unloading, cleaning. Now we have mostly almost, especially with respect to cleaning as well as drying, we have a lot of dryers. And similarly, if you see, it has to be most economical and suitable. That is what the major role plays. We may talk about everything. Is it economical? That is what we have to see if we want to commercialize, or if we want to implement into a large scale. The most important factor which needs to be considered is the economic feasibility. So you can see, starting from the how the primitive structures which were there, like, and how we have evolved to the recent structure. You can see at the bottom, see with mud, and they were using a lot of stones like Bukhari and Matkot, Khote, Morai type of storage. Starting from all the storage, similarly now even we are using the cover and plinth at the bottom. We, instead of this, we are keeping the wooden blanket we are using, and we have changed to gunny bag, and we have changed to back storage structures. And if you little consider to the improved storage structures, we started with CAR or IEI Pusa bin. That was a bin which was earlier totally used by different people. And now recently a lot of cement bin and brick and wooden structures are also now people are using. Actually from Niftam Tanjavur, not only from the food processing sector, we have the Center of Excellence in Grain Sciences with lot of facilities. And also we are looking on the safe storage guidelines to develop for different food grains, and with respect to different studies, how we can store the grains in not only to small scale level, how bag, when compared to the bag storage, how bulk storage, especially in silo and in other places, how this fumigation and other effectiveness can be made. We have done a lot of studies from Niftam Tanjavur, and we have developed, this is a part of the DSIR funded projects. Especially we were looking upon for the rural level. We have developed small bins which were there of different types of bins. We have made like a single wall as well as insulated and perforated bins we have made for the safe storage of pulses, especially for the small capacity. Around 250 kg we can able to store, and up to 1 year we could able to store the pulses without affecting their quality parameters. So these were the 3 types of bins which were fabricated from Niftam Tanjavur. And now when we talk about the bag storage, now we are shifting a lot of silos. Requirement is there. not only the requirement of silos, we have to say, the government is also presently taking lot of initiatives in order to protect our grains. So we are shifting from silo. So if you see silos, already lot of silos are there, lot of private players are there like Adani, Naga, they are successfully storing huge quantity of wheat is being already experienced, successfully it is stored. Basmati rice also now they are storing in huge quantity. But what about the grains which we need to store, which are left with very huge quantity? So if you consider the government, if you take, they are now concentrating on the model, which is nothing but the hub and spoke model. It is nothing but the model which will create a lot of silos throughout in different districts of India, different states of India. They wanted to have different silos, and the main concept of the hub and spoke model is all the silos we wanted to create through rail connectivity. So this is what the model they are experiencing. And now if you see already 12,875 lakh metric tons capacity of silos are being already installed in different places in India. Even recently in Tamil Nadu, now we have like near Chidambaram, Sirgali also, they have created a lot of silos. So TNCSC and other players also, they wanted to give importance for the silo storage, so that now we are in a shifting stage from back to silo storage. That's what now I want to say. So not only the big storage capacity, now what is our engineers can play a major role creating small silos, cost-effective silos for farm level. So now even the farmers, they require 1,500 to 2,000 capacity each silo, small capacity, those who want to store. They also look upon, apart from the grain processors, flour mill, rice mill, dal mill. So a lot of people, they require small scale silos if this can be made in a cost effective way. So that is what we need to see apart from our FSI, CWZ and others. So the capacity, we need to see the different various capacities of silos. That is what the present requirement of the nation, as well as the responsibility of the engineers to look upon, to develop for some of the structures which are cost effective for the safe storage of food grains. So if you consider the major loss where we are experiencing is with the insects, right? So that is what now we are going continuously with the fumigation purpose. Now we are going with the aluminum phosphate fumigation. So just most important factor which controls or plays a major role during storage is the insect. So if you want to control the insect, the whatever the structure you are using, where we store, that as the fumigation is being done, that should not have much of the losses. If you consider bag and bulk grain, the fumigation losses are very high in case of bag storage, and also the required concentration to reach, that takes more time because of the losses, and there is no proper covering of the bags also. So there is a chance under this sublethal concentration, there is a chance of development of resistance. Already we have reported through studies more than 100-fold resistance to phosphine. So what we can think? So this much of resistance is being developed to the population of insects. And we need to see, when we are thinking about the penetration, now also still in many of the developed countries, they are storing in silos. There also they are using the phosphine tablet only. So they also found that the penetration as well as distribution is also good. So when again we can think of introducing phosphine not only as tablet, we can able to purge in the gas form. So a lot of gaseous formulations of phosphine has been introduced in various countries along with carbon dioxide combinations, which were proven more effective when compared to our phosphine tablet alone, as well as the sensors to detect the phosphine losses. That is what very important that we have to see. And if you see the silos, now we have two types of silos, like flat bottom silos as well as the hopper bottom silos. Both can be used for the long term storage. And generally, if you see, they all are made up of metal sheets, galvanized metal or RCC. So with the use of sweep, auger, the material at the bottom, we can unload generally how we are doing it in our warehouses, first in and first out principle. The similar principle can be taken here in the silo also. Similarly, if you see the hopper bottom, this is also being used, and little bit it is expensive in compared to our flat bottom bins, and we need to see precisely, we need to go for engineering. Now a lot of agencies have come up and they are doing a lot of silo structure fumigation designing. Apart the primitive, you see the concrete silos are there, then steel silos we have. Apart from, we are having the silo bag. Morning, Dr. Anand might have told the importance of packaging. The same thing, if you see, again, silo bag is also playing a major role, especially this is being used in many of the countries also. The major principle here is like hermetic storage only. It maintains the grain in an hermetic environment. So it is keeping the air tight, because completely we are instructing to fill the grains full, and the quality of the grains are being maintained. And it also reports that very less insects as well as the fungal attacks are being found. And if you see, it is nothing but the modified atmospheric principle only we are modifying. So low oxygen as well as high carbon dioxide you can see inside when we store it to the silo bag. So they are having the 3-layer co-extruded 3-layer polyethylene bag. That is what being used. We can see it as white, especially mainly for filtering the UV. And you can see again, if you see the 3rd layer will be black. So to keep again the sunlight away. And if you see this thickness, it comes around 220 micron thickness. This is there, and various capacities they are having. This silo bag, if you see 150 to 200 tons up to we can go. There are different capacities are being there. And if you see the life cycle of these silo bags, that varies from 18 to 24 months, especially if we keep it in an open storage. So we can go in an open storage structure. In Sudan, it is majorly used in the open storage structure. And again, if you see the modern storage structure, we are having like these sheds we are having, which are very low cost, as well as we can store large volume. And it is made of steel or corrugated sheet, which are constructed with flat concrete, as well as bitumen floor is there. And we can see commonly our Central Warehouse Corporation now recently modernized grain storage structures are being constructed. And apart from silo, we all might have known and we all might have seen about the silo storage. Apart from the other storage, what is using is the bunker storage. It is not for long-term storage, it is for short storage. Suppose if there huge quantity is being harvested, especially if they see they will be going for the contract farming, all will go the same variety, all will be harvesting in the same time. So they need some space temporarily to store, not to invest much on the storage structure. So it will be like a small bin or compartment will be there, where you can store large bulk of grain temporarily for a short period of time. Okay, that is what this storage we are doing. Commonly, this is being done in open storage structures surrounded by small, low retaining walls will be there, and we will be closing it with the plastic sheeting. This method is commonly used in Australia, America, Turkey, as well as in Israel. Especially in Israel, it is very famous, and they have experienced better results and good, excellent results they have got it during storage of barley as well as wheat or being stored. And you can see this is what the plywood bunker. So any sort of material we can use it. So these bunker sheets are being formed into a round shape, and then even we can alter. And this inside they will be putting all the grains, they will load inside this, then they will cover using the polythene sheet completely. They will cover it with a complete sealant. So this can be used for around 3 to 6 months temporarily. If they want in any places, they are going for this plywood or any sort of material can be used for the bunker storage. During the bumper harvest season, they are storing this bunker storage. And similarly, even the wooden, a little bit it is costlier. You can see side bottoms are in wood. Even it will be like how our traditional wooden is there at the bottom. Wooden sheets are being used, and at the top, if you see, plywood sheets are being used to cover. So this is what the constructor method which they are using. Again, they will be having the provision for ventilation, and if you taking putting the grains and other things. And the simple technology which can be very cost effective, that is what the hermetic storage. It is not a very high-fi technology. It is an old age technology, but it is picking up as a modern technology. So you can see now airtight small containers to now how we are using for milk. And then we started with small storage. If you started, we started with the airy bags that was earlier used. Now, lot of companies are into the market, especially for producing the grain bag seed. You can see a lot. If you see into Amazon and anything on the website, you can see a lot of bags which are coming up, especially for the seeds, grains, and other material. So even triple layer bags are there, laminated bags are there. So a lot of bags are being used. And especially this hermetic storage, we can suggest, especially for the organic commodities. Now, what everybody is asking, one side, though we talk about the disadvantage or something about organic, one side, the organic market is potentially growing. If you see the India's organic food market, it has the potential to grow the annual growth rate of 20 to 22%. So the market of organic food, including export, is currently valued around 1,000 crore. So if I say any commodity organic, not only growing organic, till it reaches the consumer, it has to be organic. So during storage, what? You have to store without any chemicals. Especially we have a lot of things like Panchakavya, so many things, neem-based extract for spraying in the field we have. But what about in storage? So only one better technology which is cost effective can be the organic, especially this hermetic technology we can say. And especially in this, we can store them without any pesticides, and also without any residues or toxins we could able to store. And the quality of the grains are being stored, and it is more cost effective and feasible method, very simple method. You don't need to have any technology, and this can be used for even long-term storage of the food grains. And this is what the study what we have done from Niftam Tanjavur, and we have used three sort of bags like gunny bag and PP bag as well as storage. It is nothing but one of the hermetic bag. And if you see during storage, I don't need to say to the engineers, the thickness of the material as well as the water vapor transmission rate is very, very important. So you can see the gunny, how the water vapor transmission, and the bags which are the what we could say, the hermetic bags, the water vapor transmission rate is very, very less. That is what the reason, the moisture migration as well as the air. That's what spoiling the commodity, which is less in case of the hermetic bag when compared to our primitive gunny bag as well as even in PP bag. Similarly, now apart from this bunker storage, now the cocoon is a structure which is also coming up, and it is being successfully used, which is nothing but made of the flexible polyvinyl chloride PVC, which is having an excellent barrier to gas as well as water vapor. And you can see the thickness is very, very high when compared to any storage. That is what 830 micron. It is made up of this cocoon. It is very heavy actually, but the storage in open environment, you can see it can be used for 5 years. And we have also conducted a lot of studies at Niftam Tanjavur. And so we have used different types of bags and different combinations for storage of pulses, just I want to say. And if you see the multi-layered bags were found to be better, then again, even individually, if you also hermetic storage is considered as one of the good method. And so this is what we have done at Niftam Tanjavur during 2022. So 2 metric ton small bag we have used, which is called as cocoon. This is what the bag, where we have stored the pulses. You may not imagine. So we have stored it for 1 year in open. Even during heavy rain and downpour, this was there in the open storage structure. And we have not gone for any sort of fumigation. So we could store the pulses, especially what we stored was the black gram. We have stored it up to 9 months actually. We opened after 9 months. So we have a provision here for measuring the gas concentration. And you could see that there were no insect infestation, and we could able to store them successfully without any insects. And the other major findings, if you see the moisture content of the grain being retained, there is no losses, and the protein is very, very important. We can know that any black gram which is having high protein, that batter volume matters a lot. When we keep it for long, the batter volume goes down and the quality of the grain being reduced. Up to 9 months, we could get into the storage, and there was no much variation in the initial moisture as well as protein content when we go in storing the cocoons, as well as we have seen the batter volume raise also, it was good. And this is what the grain pro cocoon, actually what I have shown, what we have done it just like this one. And it is a very bigger capacity, not like our bag. What we had earlier, just it will be like zip, like we can put it at the top. And here just we can arrange all our bags, and there will be zippers and we can lock. So they are giving around 10 years capacity. So this is what being used. Even you no need to worry about shade, we can keep it in the open storage. So this is what even many, we can say 10 or 20 thousand also we can store here in this cocoon. Huge capacity is being done in other countries. So if you see the gas concentration in the cocoon, the oxygen concentration is reduced, you can see dramatically. And similarly, the carbon dioxide concentration is being enhanced. That is the major reason for which the insect infestation and fungal attack were less when we store it into the gas tight environment. So this is what a small work which was done from our side, I have said. And IFTM Tanjavur is working globally, partnering with different institutions, and we have got a project that is a grain care project with the aim of smart warehouses with the application of electronic based technology. Now IoT based sensors are coming up. Biosensors, Dr. SHANMUGASUNDARAM sir will be talking next. If you see the universal moisture meter, that is a common moisture meter which is being used. And mainly when the grains are coming into the godowns, to small scale level we are drying and we are keeping. And similarly, when it is coming in huge scale in the warehouses, it is very difficult to, even we can check the moisture content, but same time we can allow up to 16% now we are allowing for the paddy, but very difficult to dry. So here, if you see, this is what from IFTM Tanjavur group of scientists have taken up this project along with the SIDAC Calcutta. And this is what the RF radio frequency assisted drying system they made. So here, this will go into this belt, whatever it is coming, the grains which are coming into the warehouses will go into this belt, and the moisture content of the only monitor, and there will be drying will be done before going into the storage. So this is what the other important thing that has been done. And IoT based sensor is being provided, and it will provide the data of different warehouses, what is the moisture content in different places where we are storing the grains, as well as phosphine monitoring system is also being done. And this is what the Indo-UK Collaborative Grain Care Project with the Brunel University, London, as well as Enquiring Mind. We had this. Mainly, if you see the problem is temperature as well as RH monitoring is very, very difficult, and we do not have any data. So based on our IoT based technology, what we have got it, this is what the development of small sensor, which is IoT based sensor, which can provide the real time quality of the stored grain. So it can provide what is the temperature in RH. Suppose if it is stored in Raipur, the grains, what is the temperature during different storage of at a different time, what happens to the grain. So we are getting the data. So this has been already successfully installed at Raipur. So you can see here we are getting what is the temperature and moisture. So automated control measures we can make. So this will also give an indication. Suppose if it is the moisture or the RH is going more, what to do? If it is more than 14% or 12%, do we need to go for drying? Or if it is more than 40%, we can go for aeration. So such sort of alerts are also can be given through this. And about the smart warehouses, that is what we have to shift now. Slowly we are shifting to back to bulk now with the silo. And also, especially fumigation is a very important thing. So we need to have the fumigation on-site monitoring system. That is very, very important. So we have to measure the phosphine. We have some sensors just real time. What is the thing is there? Whether fumigation loss is there, and we need to see. So online on site, not only monitoring the purging automatically. Suppose around 1,000 ppm of the phosphine is required because of some losses, atmospheric or physical damage or something. If only 800 ppm is there, immediately it has to give some alarm and we have to go for purging into 1,000 ppm. So such a smart warehouses with fumigation on site monitoring system is very, very important if we wanted to completely store our food grains as a modern technology to think of. And drone technology is being very well employed. If you see all the purposes, even including agriculture, now a lot of subsidy is being given by the government, and a lot of people now they are giving a lot of importance to the drone technology, those who wanted to use. Similarly, we may also in future, we may have the drones specially to monitor, or maybe for requirement of for fumigation or anything, especially fumigation, man only now we are involving. That is a major disadvantage. Phosphine especially, it is very, very harmful. One of the potential gas which is very harmful, we can say. So that can be done through drone technology, as well as nano pesticides. Now we are into the for the field pests, and again for the stored pests we have to look upon. And now especially for the seed purposes, in many of the countries now they are using the diatomaceous here, diatoms. From the diatoms they are taking compounds, extracting, and they will be having a lot of corrugations or sharp edges. So whenever like our sand only, just they will be mixing this diatomaceous air and they will keep it for storing. So because of this sharp edges, any insects or their stages are there, so they will be killed. So this is specifically they are recommending for the seed purposes. Again, we can think for the grain purposes, what sort of formulation that can be made, or what sort of herbal biofumigant that can be developed. That is what a very, very important we have to say. And also for the controlled as well as modified atmospheric storage. Now for the fruits, we are going again, if you wanted to go for the smart warehouses, this is another important aspect which we all need to be considered. So thank you so much for the given opportunity from NIFTM Tanjavur. I would like to sincerely thank. And still we are in a primitive stage of grain storage. We need to go a lot, and whatever the other countries they are taking from that, now we have to look upon. And mainly from the engineers, we need to develop some of the small storage structures which can be adopted at the small scale level. Thank you, sir. Thank you so much.
Thank you, Meenakshi. Really, it was wonderful to listen to you about the methods for reducing the post-harvest losses in food grains. And it was very exhaustive as well as the very useful information. And the audience must be known about all these useful techniques available in NIFTM Tanjavur for controlling the post-harvest losses, maybe in the delta, maybe in the whole country. Thank you very much for the wonderful presentation. Thank you.
Thank you, sir. I'll log out.
Yes, you can be in the line, no issue.
Yes, yes. I'll close my slides.
Yes, yes, you can close your slides.
Yes, yes.
The next speaker will be Dr. SHANMUGASUNDARAM, whether it is joined. Any questions from the audience? Dr. Meenakchi is here to answer the questions, if any. Meantime, our next speaker will also join. I think there is no questions. We can move on to next session. Wait a minute.
I hope most of them visited our institute, and we are having an excellent facility from Center of Excellence in Grain Sciences as well as Non-Thermal Sciences. So those who have missed, maybe they can come here and visit, and student internship projects also they can take up, so that you can tell to your colleagues or any student, those who wanted to take up internship projects also we are supporting. From NIFTAM Tanjavur also we are availing we are providing the consultancy services in different areas. We are providing oral as well as technical consultancy we are providing from NIFTAM Tanjavur. Thank you, sir.
I request all of you to stay in line. Dr. Shanmugasundaram is joining now. We will start after he joins.
No problem, sir. We'll wait.
Yes, yes.
Any questions? Anybody want anything to be discussed?
I think you might have told something about entomophagy, so that it is very useful new topic to the audience. Maybe till Shanmugasundaram joins, maybe 1 or 2 minutes, maybe you can share about entomophagy. MEENATCHI?
Sir, please, sir.
Till Sasu joins, you may spare some 1 or 2 minutes to explain about entomophagy, which is
Yes, yeah, very important thing actually. Now, again, one side we are talking about the food security. Insects are damaging, correct? And they are causing a lot of damages. Being an entomologist, I have to see how to control insect. And another way, basically working in food processing institute, we need to see the potentiality of using insects for food, because it is not just a new topic or something new. Even from the Romans, if you see Historia Naturalis, very long back, you can see they have used insects in soup and other things. Romanians time onwards they have used. No, but it was used, and till now also, if you see, insects are being used in many of the northeastern states of India. They are consuming insects in different forms. They are using the insects in fried form. They are using, as well as they are using as raw form. They are using, and they are boiling the insects. They are using soups. This is what the traditional way by which right now people are consuming. There are a lot of farms, especially for the insects they are making, and mainly they are using these farms. Even in Bangalore, we have a farm. And if you take the World Health Organization Millennium Goal, poverty should be reduced, and we expect by in another 10 years, very fold increase in the population. So they consider that there will be definitely very acute shortage of food grain. So we have to depend on some of the sources, like we have to depend on the aquatic sources, and insects are one of the domesticated animals on this earth. We can say early domesticated animals are, which is highly persistent animals on this earth, we can say. So even in cockroach, you might have seen after a nuclear war also, after bomb also, some of them, they were there in that. So insects are prone to be one of the more resistant organism in this earth. So they are having a lot of protein in it, especially silkworm. If you take the silkworm is very rich in protein, and animal protein and plant protein. Again, if we look upon the animal protein to take, we need to spend a lot of money, whatever is required, and it is very costly. But this small primitive insects, they are very cheaper, only one small space we need, and we have to use for growing these insects. What we need is just whatever the waste which are there from the food processing industries, that can be used in order to grow the insects, and we can extract this protein from the insects and we can make a lot of products. It is already available not only in India, globally. If you take cricket flower, cricket is considered as one of the very potential insect, and they have extracted protein from that. And this cricket flour, like how we are using all purpose flour in bakery product, everywhere they are using. Similarly, if you take insect based fried products are there, and health drinks are there, immune drink, in the name only it is there. Similarly, from Niftam Tanjavur, we have also developed from chocolate, which is made using the silkworm pupa protein incorporated into the chocolate we have made. So similarly, lot of products, especially in the developing countries, now going on the alternate protein, especially insect based protein. Now they are commercialized, and CAGR value, if you see globally, it is very high. So alternate protein is a very, very important concept, and we have a lot of protein deficiency. The major problem with plant protein, we have few sources which are very rich in protein. And similarly with the animal protein, if you want to talk, the major problem is it is taking a lot of greenhouse gases emission is there, especially if you want to grow any animal. Lot of emissions are coming out, which is harming our environment. When compared to the insects, it is very, very less than 1%, even we can say 0.0% only the emissions are there when we compare to the animals which are emitting a lot of greenhouse gases into the environment. So this is also one of the viable method where a lot of people are looking upon the entomophagy. And regarding the sensory analysis also, if you consider about the taste, whether will it be good or bad, you can think, I'm a pure vegetarian. I never consume any non-vegetarian food item. But frankly, sometimes I eat cakes where egg is hidden, right? Egg is added to it. Similar way, many people, those who are vegetarian, they will be compelled to eat based on the health nutritional consideration. They will be taking the fish oil in tablet and other thing. Similar way, if you wanted to eat insects as such, people may have some of the aversion. But when we they are interested to take as a protein part, when we extract the protein and when it is incorporated into a food item, definitely there may not be any constraint. Already a lot of countries are now popular with the insects as food, as well as insect incorporated food items are there in lot of market. There is a lot of demand and a lot of products are also being used. And right now, even in India, in many of the northeastern states, now we are taking this insects as our food, not even based on traditional product also. I think Dr. Shanmugasundaram sir has joined a little bit 10 minutes before I have completed. So I have also given about another topic. So maybe you can also think of new revelation in this also. I think sir will be sharing his slides in few minutes. He has joined with us.
Thank you, MEENATCHI, for sharing about introduction about the entomophagy, because the audience will be knowing about the new area of research where the deficiency in protein availability in the world, and everybody is looking for alternative proteins. Even today evening, we are 5 o'clock. We are having one more separate webinar on alternative protein. So definitely your introduction will be helpful to the audience. And also once again, I thank you very much for the wonderful talk on reducing post-harvest losses. Now, friends, now we'll move on to the next session by Dr. S. Shanmugasundaram, the registrar of Niftam Tanjavur, and also heading the Planning and Monitoring Cell of NEPTM Tanjavur. Will be delivering about a very interesting topic about sensors. And it's a very upcoming field, and definitely this lecture will be an eye-opener to many of the audience present here. To introduce Dr. Shanmugasundaram, he has obtained his doctoral degree in Food and Agriculture Process Engineering from Tamil Nadu Agriculture University, Coimbatore, and he served as the senior lecturer in before coming here in CARNIVAL University, and then he has worked as a scientist as a part of Agriculture Research Service in Indian Central Institute of Agriculture Engineering, Bhopal, for a short term. And he has published numerous number of research and review papers in national and international peer-reviewed journals. And he has undergone the foundation course for Agriculture Research Service, POCAS, at NAM, National Academy for Agriculture Research Management. And also, he has worked in the private sector in the dairy industry for a short time. And he is teaching all the courses related to food process engineering, food and dairy engineering, and agriculture process engineering. And he is nowadays he's working on mainly on sensors in the different food commodities. So his research interests includes micro and nano encapsulation of food flavors, colors, and nutraceuticals, and development of enzyme-based bio and nano sensors for food industries, and development of microwave retorting system for passing of indigenous foods. So the talk will be very interesting. So I request all the audience to listen to Dr. Shanmugasundaram for a wonderful talk on sensors in the food industry. I pass on the mic to Dr. Shanmugasundaram and invite him to deliver the lecture.
So, thank you very much, sir, Dr. MEENATCHI, sir. First of all, my thanks for the opportunity to the Institution of Engineers and the delegates of Institution of Engineers and president, different officials of Institution of Engineers, as well as audience of this webinar. So today I am going to cover biosensors and innovative approach in food quality evaluation. Nowadays, we are aware about that all are moving towards personalized nutrition, as well as without any adulteration. They are very conscious about what they are taking. They want without any pesticide residues, adulteration, and antibiotic residues. Also, they want to know what type, what calories they are taking, what is the composition of nutrition they are taking. All those things they are very much interested, the public. But it is possible with chemical methods or high-end equipments, like chemical methods mean titration, pH meter, plate techniques, and high-end equipments, GCMS, HPLC, LCMS, MS. Also, we need DSC, all those things. These techniques are different stages: sampling, sample processing, and analysis. This limitations in the existing techniques are the cost, very costly one, as well as it takes more time for sample preparation, and we cannot able to take to the site where, for example, we are in the field, we are buying the samples. We cannot take, not portable. It is a complex instrumentation, as well as a time consuming process. So one of the alternative method for quick detection of this analytes, biosensor is one of the possible solution. A biosensor is nothing but analytical device used for detection of analyte, what we are going to measure, either biological or protein or microorganism or whatever it may be. It measures the biological and chemical reaction by generating signals proportional to the concentration of analyte in the reaction. For example, I want to measure the protein concentration or microbial load or some pesticide residue present in the food. So we have to select the bioreceptor. It may be enzyme based or antibody based or microorganism based. So it reacts with our analyte. For example, I want to measure a pesticide. It reacts with a particular enzyme. It will give the reaction. That reaction will be quantified using the transducer. It may be electrochemical transducer or optical transducer or mechanical transducer. So this reaction output will be directly proportional to the amount of pesticide present in the our food product. Okay, that is the basic mechanism of this biosensor. So this is a bioreceptor. It may be the antibody or enzyme. So it is connected with the transducer. Our bioreceptor will be enzyme immobilized with the transducer. So for example, our analyte will be our red color dot. So it will come and combine with the receptor. It will give the reaction. That reaction will be measurable signal. Okay. So how much measurable signal is directly proportional to the our analyte compound. For example, if only solution is there, no that analyte maybe pesticide or any toxic compound is not there, it won't react with the receptor. So there is no measurable signal. This is a basic mechanism of this biosensor. Same thing only here we explained in detail. So even sometimes after transducer, the signal is somewhat very weak, and during that time we can amplify the signal and then we can give the more accurate readings using this biosensor. So application of this biosensor, all the fields they are applying a very large, either in the case of environmental, even medical diagnosis, even drug development, all the places this biosensor is applying. Even food processing sector also they are applying nowadays. Even lot of research is going on for development of biosensor in the food quality evaluation, especially. But features of this biosensor concept is targeted specificity. Even for example, different pesticide compounds are there. We want to know only a particular pesticide compound, how much residue is there. That is also possible using this biosensor. Accordingly, we have to select the bioreceptor. The particular pesticide compound should react with the particular bioreceptor. Accordingly, we have to select. So it is an electronic integrated one. Even we can operate in the complex matrix also. Even fast response time. Even small size, cost wise lesser. These are all the features of this biosensor technique. So different types of biosensor we can classify in the 4 different categories. In terms of electrochemical biosensor, it may be based on the reaction, either amperometric or potentiometric or conductometric biosensor. In the optical biosensor, based on the light waves, reflection, refraction, those things, it will be colorimetric, interferometric, fluorescent or luminescence. And based on the reaction between this one, if heat is generated, that is a colorimetric biosensor. Even piezoelectric and acoustic wave for the mass-based biosensor. These are all different types of biosensor we can classify. Bioreceptor can be either, it may be DNA based like aptamers, even enzyme, or even we can use as a microorganism as a bioreceptor. Otherwise, antibody also we can use for this purpose. So we will go in depth about the electrochemical biosensor in this lecture. Electrochemical biosensor rely on the direction of a direct electrical signal between the bioreceptor and analyte. It will measure the electrical signal. There are 2 types. One is a potentiometric biosensor, another one is the amperometric sensor. So between the reaction between the analyte and the bioreceptor, there will be a change in potential due to accumulation of the ions that will be quantified in the electrode surface. That means it is a potential electric. during the reaction between the analyte and bioreceptor, the free electrons will be produced. The flow of electrons causes the change in the current. So it may be due to oxidation or reduction reaction. So that will be the amperometric sensors. So these are all the different type of electrodes used in this field. One is a 3 electrode system, a screen printed electrode, even Clark type electrode is there for it. It depends upon the what type of analyte we are choosing, what is the reaction happening between the analyte and bioreceptor. Even this screen printed electrode, it's like a chip like that. Even we can carry in hand, even the software will be integrated to the mobile app. So directly we can measure the readings actually. So materials of concern electrode, the transducer is play a major role in that. Electrodes are because reaction between the analyte and the bioreceptor is taking place above the electrodes. That's how we are selecting the electrode surface will play a major role, because that surface creates the environment for the reaction. If environment is perfect, our accuracy will be very higher. So we can classify the electro materials will be metal, carbon based or modified. Each metal also platinum or gold. Carbon based electrode means graphite, classic carbon or carbon based. Even nowadays modified electrode surface also we are using nanoparticles coated, even dye also we can coat, and then mainly for increasing the efficiency and the repeatability and the reproducibility of the sensor reaction. So criteria for selection of electrode, either characteristics of the bioreceptor. Mainly, first of all, we have to see what is the analyte we are going to measure. If we are going to, for example, if we want to measure the adulteration in any compound, what type of adulteration for sugar they are mixing with the milk means, if you want to measure some milk sugar content, accordingly we have to select the bioreceptor. Then between the analyte and bioreceptor, what type of reaction is taking place, that also we have to see. Accordingly, we have to select the electrodes. So with this background, we will move on to the applications in the food. Some of the application we can discuss for a better understanding. The detection of urea in milk, as we all know, for industries, they are paying the milk for vendors based on the how much total solid content in the milk. So what they will do for increasing the total solid, they will add the urea. Accordingly, the SNF will increase, the total solids also will increase. So for this detection, so this urease enzyme is used as a bioreceptor. In the urease enzyme, in presence of in the milk, in the presence of water, what will happen? Reacts with the urea, it will produce ammonia. Again, it reacts with the water. It will release the OH plus free electrons. So this free electron will release in the electrode surface that causes the changes in the accumulation of this free electron, causes the change in potential. So how much change in potential is directly proportional to the urea present in the milk. This is a basic reaction. This is one of the application of this biosensors. Next one is detection of adulteration in ghee. Ghee is adulterated with vegetable oil, even sometimes animal fat also for getting the profit. So what will happen during the adulteration of ghee with vegetable oil? What will happen? Tocopherol content will be increased. Okay, that can be measured using the biosensor. So causes a change in current. So the change in current is directly proportional to the tocopherol content. So based on the tocopherol content, we can identify whether ghee is adulterated or not. Otherwise, for identifying the tocopherol content, we have to use the GCMS, HPLC, all those things. Next one is quality evaluation of coconut milk. Nowadays, after COVID-19, the acceptance of coconut milk is increased. Our major issue is rancidity, actually, spoilage due to oxidation. So that can be determined using this biosensor. Here, what will happen during oxidation process? Triglyceride present in the coconut milk will be breakdown. It causes increase in free fatty acid content. So instead of measuring free fatty acid content in this biosensor approach, we are measuring the triglyceride content. Then we are correlating with the rancidity and free fatty acid content. Here also we see lipase is our enzyme. These are all the cofactors, GK, MgCl, all those things. This reaction will be all this reaction will takes place in the electrode surface. Finally, the free electrons will be released. That free electrons will cause the flow of current in the change in the current in the electrode. So we can measure how much change in current. The change in current is directly proportional to the amount of triglyceride present in the coconut milk. This is one of the application. Nowadays, Italy better purchase has been increased due to urbanization, also office going both family members. So what will a major issue while buying, we cannot understand whether it is fresh one or acidic Italy batter. So this is one of the technique. What will happen during acidification process? Organic acids will be produced, mainly lactic acid. It causes increase in pH. So that can be measured using this lactose dehydrogenase as an enzyme in the biosensor. So it reacts with the lactic acid, it will produce the NADH. Again, it will break down hydrolysis into free electrons will be produced. That will be directly proportional to the amount of lactic acid content. So here now in the future, this biosensor itself, we can attach like a strip in the packaging film itself. So while purchasing itself, if open this one, automatically it will show the what type of what is the acidic condition of this Italy batter. So that is also possible in the future. Now also smart packagings are coming up. Next one is another area is maturity and the ripeness indices of fruit. Certain fruits we cannot able to identify how much will be the maturity as for harvesting, as well as we while buying in the market we cannot able to distinguish whether unripened or ripened or not. This is we can use this biosensor method. Here, what will happen during the ripening process? Concentration of glucose increases as the maturity progress. Okay, so we can measure the glucose using this technique. So, what will happen using this reaction? Glucose oxidase is used as the enzyme. So it will cause us a change in current in the electrode. We can quantify the how much quantity of glucose percent. Even one more method is also Clark method, in that how much oxygen consumed during the H2O2 production. That also using Clark type electrode surface. We can use that technology also for identifying the ripeness of the fruits. So this is also one of the approach for food quality evaluation. Then as we are acrylamide is a one component. It will be formed during the frying of foods. It is very carcinogenic. Even though it is a colorless, odorless compound, it is a very carcinogenic. Even a lot of limitations are there. So even reusing of oil, even small street vendors they already used oil they are using for the frying of for cooking of foods, all those. It causes the acrylamide formation. So that can be detected using the aptamer based biosensor. In that case, a single stranded DNA and hemoglobin is used as a receptor. It indicates directly how much quantity of the acrylamide content present in that. So next is the mycotoxins. Mycotoxins are thermostable. low molecular weight natural compound produced as a secondary metabolite by a certain fungus. When what will happen? This mycotoxin will be produced based on the fungus reaction. So it causes the toxicity. Even for example, if you take spices, aflatoxin B1 will be there. It is a major issue for exporting spices from India. If any aflatoxin is there, total container will be rejected. Even if you take milk also, aflatoxin M1 will be there. Even next one is major issue in the wine production. Aflatoxin A is there. So that is a major challenges they are facing during the export of wines as well as during aging of wine also. Next one is a botulin in juices, mainly apple juices. That can be detected using the antibody-based amprometric biosensor. So only thing is we have to select the specific bioreceptor that has to be act with the aflatoxin. So we can identify the how much quantity. Not only whether aflatoxin is there or not, even using this biosensor technique, we can quantify how much quantity of aflatoxin present in that. Next one is next recent lot of research is going on for detection of microbial quality in food, because while going for a standard method of microbial detection, we have to wait for 24 hours or 48 hours. It depends upon the either fungi or bacterial or actinomycetes. So here by using this micro biosensor, we can immediately we can detect this one. Only thing is we have to develop a algorithm also with a different concentration of microorganism. That is the only thing, but we can able to achieve better accuracy. So here nanoparticle based biosensor for increasing the modified electrode surface they are using. Gold nanoparticles and silver nanoparticles, even magnetic nanoparticles they are using for specific purpose. Actually, here a lot of research is going on in this field, because this is a major need for the industries as well as all the food quality control people. Even peanut allergens also major issue. For example, if you take Artis hypoxia, it is a heat liable allergen in peanut kernels. It causes irritation and itching mouth and digestive problem. So here we have to use either GCMS or HPLC for quantified detection of these allergens. Here we can use the polyclonal antibodies can be used for this peanut allergens. Next one area is freshness indicator of fish. During the storage or cold storage of fish, what will happen? The hypocytin is a purine derivative. That content will be increased. So that will be used as an indicator whether to identify the fish is fresh fish or cold stored fish. So here we can use xanthin oxidase as enzyme. It reacts with hypoxanthine in the presence of oxygen. So hypoxanthine is direct. Finally, the after reaction, what will happen? The free electrons will be produced. That causes a change in current. So how much quantity of change in current is directly proportional to the hypoxanthine actually. So this is one of the technique. Right now they are using the eyeball of fish for identifying a freshness on them. So this is an accurate method. We can identify whether how long cold stored or what. Next one is next major thing is nowadays the market organic these organic foods are coming, organic vegetables, those things, organic grains. Organic food market is increasing, but everybody having doubt on that whether it is organically grown. any pesticide residues are there or not. So here there are mainly 4 major groups are there: organophosphorus, organochlorine, and carbamates, and the synthetic pyrethroids pesticide are there. That also can be detected using this one. That we have to use the acetylene acetylthiochlorine. So during the reaction, that free electron will be accumulated in the electrode surface, that causes the potential difference that can be quantified. Change in potential difference is directly proportional to the this one. But here a major limitation for use for this biosensor approach is each pesticide group needs a separate bioreceptor. Okay, all the places research is going on. For example, organophosphorus, they are detecting they are developing one biosensor with a specific bioreceptor. For organochlorine also they are working, but the need of the hour is multi-target electrode, screen printed electrode we need. If you take one screen printed electrode, one biosensor, if you put the sample, it can able to quantify how much quantity of organophosphorus group is there, how much quantity of organochlorine is there, how much quantity of carbamates is there. It should tell. Okay, that's research is going on. Nipam Tanjar also we are working on that for detecting multi-targeted pesticide detection. Definitely this is a need of our for this identifying as well as visualizing what we are purchasing, that is organic food or not. Actually. Next area is antibiotic detection. Even honey and all, they are using the antibiotics. So that causes the antibiotics residues in the honey. So that either it may be tetracycline or oxytetracycline or chloroamphetamine. So these are all the antibiotics they are using. So that in the export market, that is a major concern. Antibiotic residues are there, they are rejecting. Actually, that also can be quantified using the biosensor. We have to select the specific antibiotic analyte. For that specific bioreceptor we have to select. What will happen? It will, after the reaction, there is a change in potential due to surface. Already the detection molecule will come and occupy the places. So accordingly, reduction potential will take place. Actually, this is one of the things. Next one is during storage of beverages, what will happen? The benzene formation is formed. That causes the carcinogenic. It can be identified using the biosensor approach. In here, they are using the Pseudomonas data on the sensors of it. That is a microorganism. So that causes the oxygen utilization. So it can be quantified using the Clark electrode. So it causes in the Clark electrode change in current readings. That will be used. Apart from this, lot of research is going on. Nipam Tanjavur also related to for detection of microorganism, as well as even for quantifying the how much quantity of infestation takes place based on the uric acid content. For example, in the Central Warehouse Corporation and all, so they are doing the phosphine fumigation according to the infestation level. So very difficult to measure how much infestation can be there. There is a research is going on quantifying the infestation level based on the uric acid content in that research also going on. Apart from this, now we are doing even for printing of screen printed electrode according to the need of the that research also going on. So mainly we can develop biosensor. Mainly we have to see the performance characteristics of biosensor. Either it may be the accuracy. It has to give the repeatable same results wherever every time if you are doing also. Even reproducibility, even if you are doing in Tanjavur or Chennai, it gives the same reading. Even same issue has happened during the COVID-19. the what will happen? The quick detection kits they purchase from the foreign countries. They developed the correlation. They validated with their country. After importing to India, what will happen? Its work. It is not working properly, mainly due to the validation. Again, after coming to India, it has to be validated. So that is very much essential before starting biosensor research. If you are using the biosensor, according to the condition, we have to validate once. Then response time, how much quickly it gives the result. Next is stability of the electrode, because we are using the bioreceptor. So what will happen if you are using the enzyme as a bioreceptor? During the storage of electrons, what will happen? The activity of the enzyme will reduce. If activity of enzyme is reduced, automatically the accuracy of the biosensor, developed biosensor will be reduced. That also we have to check how much stable it is. Accordingly, we have to develop an algorithm for that. Major challenges is the external factor, because we are using the bioreceptor. It depends upon the outside environment, temperature, even pH, what type of condition we are using, even storage stability of the electrode. Also, low cost receptors. What we are using is enzymes, antibody, all those. It is a costliest one. We have to use the readily available by either plant-based or animal-based directly, instead of extracting the enzyme and then using for this one. Directly, we have to use some plant-based material or something. So that type of research also going on. Even reuse of electrodes, how much time we can use the electrode without any contamination, and the sterilization of the electrode. These are all the major challenges happening in this field. These are all the commercially available biosensor in the food quality control, different parts of the web. For example, France, they are having lactate measurement biosensor. So some of the industry, they are using this technology. So with this, my conclusion is, as per FAO, around 45% of the food products worldwide contain substances which are not visible to eye and which are toxic one. So this biosensor approach will be the suitable one. Only thing is, it is an interdisciplinary approach. It is a combination of food technology or biochemistry, electrochemistry, physics, and engineering. All this field together, they have to work together, because now what is happening, food technology alone separately, they are doing research in the food quality evaluation. Other biochemistry labs, they are doing separately. But interdisciplinary approach is required for better accuracy in the future for this one. So it is a small survey from the nanosensing, biosensing market is increasing everywhere. Even food industry also is increasing compared to other fields. So future aspects will be nanoscience. Instead of using the enzyme for increasing the better, we have to use the nanoscience. Next concept is microfluidic. Microfluidic means lab on chip. That concept is also coming up well, when biosensors will be connected everywhere, and then particular quality control lab will be in the chip form. Okay, using that chip form, we can quantify the quality of the food. Also, the artificial intelligent IoT. So if you integrate this biosensor, all the sensor related to quality from the one, everybody can understand. So where it can be purchased, where it is grown, where it is done. Even during the transport of this, for example, we are transporting the milk from Tanjavur to Chennai. During the transport, what is the quality of the milk? What is the temperature, pH, and what is the acidity? All those things we can measure using this IoT connected with the biosensor approach. This is the next data is there for global biosensor market in 2024 will be around $31.5 billion US. So with this, I conclude my lecture. Thank you very much.
Thank you, Dr. Shanmugasundaram. Really, it was very interesting lecture to know about the application of biosensors in the different food commodities, starting from adulteration, maybe the components, or maybe antibiotics. It was very exhaustive and elaborative, and also the when you come to know about the market potential of the biosensors to so much billion of US dollars, definitely this area of research will be more important in the coming years. Definitely, Tanjore will be contributing for the development of this particular field in the food industries. I thank you very much, Dr. Shanmugasundaram, for wonderful.
Thank you, sir.
And also, I'm very happy that Vikram Tanjore also participating in this 100 hours technical carnival for the Limca or Asian Book of Records. So I thank all the speakers from Institute side to contribute today. To give a vote of thanks, I will invite Dr. J. Sumati, former chairperson of the Institution of Engineers India, Tanjore Local Center. Madam, please.
Yes, sir. Good evening, one and all. First of all, I thank NIFTEM Tanjavur being an institutional member with Tanjavur chapter, and thank NIFTEM director who gave speakers to conduct the centenary program in a successful manner. I thank the speakers, Dr. Sinija, Dr. Anantakumar, Dr. Meenakshi, and Dr. Shanmugasundaram, being a part of this 100 hours, 100 speakers in Asia Book of Records, and gave a wonderful speech. All our participants gathered here who gave comments about this wonderful speech in the comment box. And I thank Engineer Jay Kumar, Tanjore chapter chairman, and Dr. N. Venkatajalapati, honorary secretary, Tanjore chapter, who is the instrument to bring today's function a grand success. Thank you, one and all.
Thank you, madam. Thank you very much.
Thank you very much.